Okay, now on this margin of error and confidence intervals, on number 1, 2, and 3, you're looking for the population, sample, parameter, and statistic. Remember, your population is to parameter as your sample is to your statistic. Okay? Now remember, your sample statistic is p hat. Your parameter will always be p, and you will never know what your parameter is. Okay? So when the local school board posts SAT math scores for each high school in the district for one particular high school, the average math score is given as 516. Okay? Notice it says that's for the high school. Well, that is your parameter. So that's your 516. Now, he takes a random sample of 100 students. That's going to be your sample, and finds that their average SAT math score is 486. That is your sample statistic. So that 486 goes right here. Now, your population happens to be those who took the SAT math portion at that particular high school. Now, the population you see are the students at that particular high school that took the math. That's supposed to be took the math SAT. Now, the sample in this particular one is actually the 100 students at that particular high school. So we're just going to put 100 students. Now, I'll put 100 students. You have to remember that you have to say the 100 students at that particular high school. And I'm going to let y'all try to do number 2 and number 3 and see what you can come up with. I think we've already done this as well. Now, number 4, when you're trying to find the margin of error, remember that old saying where you ask how much something is, and they usually say, well, it's $3 and then give or take. Well, give or take, let's say 50 cents. Well, that means it can range anywhere from $2.50 to $3.50. So that is what a margin of error does for you. So the margin of error is that 50 cents. It could be 50 cents lower, it could be 50 cents higher. Now, when you use that in statistics, what's going to happen is this. If you notice up here, it'll say the margin of error for a 95% confidence interval. Well, in the media, typically they don't tell you how confident they are or what their margin of error is, but it's typically a 95% confidence interval, and then they say it, which is equivalent to about 3%, plus or minus 3%. So, in order to a quick method, we're going to use 1 over the square root of n, and remember, n is your sample size. All right, n is your sample size. So we're going to use 1 over the square root of n. So now let's look at the rest of the questions. Number 5, when constructing a 95% confidence interval for proportions, what would be the approximate margin of error for a sample size of 200 people? So what you need to do is 1 over the square root of 200. So you need to figure that out and put that as a percent or a decimal. Then, when constructing a 95%, you're going to do the same thing for number 6 with 800 people. So 1 over the square root of 800. And then it says by increasing the sample size, the margin of error becomes, does it become larger or does it become smaller? That's what you have to decide based on these two, number 5 and 6. And then the length of the confidence interval. Does it widen or narrow? In other words, does this get wider or does it get more narrow? All right, you have to decide that. And we'll go over that tomorrow when you come back into class. Now, in this particular problem, questions 8 through 12 deal with this scenario, okay? Notice that a doctor noticed that many female patients were vitamin D deficient, okay? She would like to determine what proportion of her patients are deficient. She chooses a random sample of 45 medical files of female patients and finds that 37 of them are deficient. So what is the margin of error? So basically, remember, you're going to do 1 over the square root of your sample size, which is 45. Now that is going to be roughly, I think I did this in class, 14.9%. So we're going to leave it like that. Typically, I don't like leaving it in percentages unless that's what we're talking about. Often, I will have you write it as a decimal. Let me rewrite that a little bit better. Okay, so basically 14.9%. That's your margin of error. That means it's going to be plus or minus that. Now it says construct the 95% confidence interval. Well, what you have to do is you need the p-hat. Because remember, it's the first part of it is going to be p-hat minus your percent, your margin of error. All right. And then the other part's going to be your p-hat plus your margin of error percentage. Okay? So that's what you're going to have to do. So up here, what you will end up doing, all right, you're going to take your p-hat and you're going to subtract. Now, how do you get your p-hat? That's your sample statistic. So that's going to be 37 over 45. So that's p-hat is equal to 37 divided by 45. And then you're going to add the you're going to subtract the 14.9 and put that right there. And then you're going to add the 14.9 and put that right there. Now, number 10, make a 95% confidence statement about the percents. So, I haven't gone over confidence statements. So, we will go over that tomorrow. But you kind of have to say we are 95% confident. So, we are 95% confident. That's confident. You can't read my writing. We're 95% confident that the true population, I'm going to abbreviate, parameter, falls within the interval, and then you're going to list the interval above. Okay? We are 95% confident that the true population parameter falls within the interval blank to blank. Now, look at number 11. The doctor's unhappy with the confidence interval. It is so wide she does not feel that she has a good estimate. So, based on question number 7, what could she do to narrow the interval? So go back, look at number 7, and answer that question. What can she do to narrow the interval? And then finally, if she increases the number of patient files in her sample to 180, what will happen to the margin of error? So in other words, when you increase your sample size from 45 to 180, what's going to happen to your margin of error? Again, refer back to number 7. On number 13, 14, and 15, I'm going to let you try this on your own. The last problem kind of gives you clues and hints on what to do. So I'm going to let you try this one. George Sanchez is running for the city of mayor. Voting population of 250,000. Now that's the population. That's not the sample. So 3 months before the election, George pays a polling company to survey voters to find the proportion of all voters that plan to vote for him. So look here. You have 500 voters and 236. So there's your sample statistic, 236 out of 500. That's your p-hat. So they surveyed 500. That's your n. So you're going to do the 1 over the square root of n to find your margin of error. You're going to do 236 divided by the 500 voters to find your p-hat, and then construct your interval. Then you're going to make a confidence statement just like the one prior. Okay? Now, again, it's reiterating, explain why increasing the sample size is important to George. So refer back to the last 2 problems. Okay, now in this one, you're going to do 3 months, 2 months, 4 weeks, and 2 weeks. Now you're going to complete the table using a 95% confidence interval. So, on number 16, I'm going to do the first column for you. Alright, so basically for 3 months before, you're going to take the 236, because you're wanting your sample proportion, so you need your p-hat. So this is your sample. So your p-hat is going to be your how many you asked. So 236 are going to vote for George out of 500. Now, you're not going to put that decimal there. What you're going to do is, this is the work you're going to do. And then 236 divided, so basically I'm going to put this, so 236 divided by 500. That's going to be your p-hat. And that actually ends up being 0.472. Now, you're going to do your margin of error. Well, remember, it's 1 over the square root of n, and your n in this case is 500. So that happens to be, on number 16, 4.5%. So we're going to leave it as a percent for this one. And then your confidence interval. Remember, you're going to take your p-hat, you're going to subtract, you're going to change 4.5% to a decimal, so minus the 0.045. And then you're going to take your p-hat, and you're going to add 0.045. Now that's one method, or you can change your p-hat to a percentage. So 47.2% minus 4.5 and 47.2 plus 4.5. And you can either do either one of those, and that'll be your margin of error. So I'll take either a decimal or a percent. If you want to double check your percentages, it's going to be, I think, let me just do this. It's going to be 42.7%. So 42.7, oops. It's supposed to be 0.7%. And it's going to go all the way up to 51.7. So 51.7%. And that is it.